Welcome to chemistry.
Okay, so we have all our samples loaded here. On the right hand side you see more tubes, and they're there because at the back of the sampler is a diluter, and as I said, if your samples get into a higher range than our calibration curve, we'll go over that, it'll dilute it, okay, and then run it. So basically it grabs nice clean water from the bottom, fills up the tube, and then grabs some of the sample, mixes it in, remembers the dilution factor, analyzes it, and then applies the dilution factor at the end of the run. Okay? So it's pretty intuitive. It does a lot of kind of neat stuff. You can see the peristaltic pump running over here, and that's going to get a steady sample, run a sample. So the sample comes up from the diluter through the pump and into the nebulizer in the spray chamber, okay, in there. And I'll just turn on the plasma. The torch that I showed you is in here, behind this glass. If I opened up the door, everything would just shut off, and we'd have to go through some kind of fail-safe shutdown thing. It also has a vent because we are concentrating the metals, and some of them are actually going to escape the plasma, and we don't want any of those emissions being breathed by us, so it goes out through there and through a scrubber and then inside. Okay? If you listen, this thing is just getting ready to fire up. You'll hear that's the argon gas, okay, flowing into the torch. That whine that you hear. There it is. There's the plasma. Okay, so this looks like a light in there, but if you see it's cone shaped, it's sitting just to the right of the induction coil. There's a space about this much. Okay? Alright? You can see the induction coil kind of wrapped around it on the inside. And as I said, if we open up the door, they just take the retina out of your eyeball, and life as you're seeing days will be over. Which is why they have this nice, thick welding glass. It's actually double thick, so it doesn't... I have to be able to see it because I want to make sure that the cone is in the right shape. It's not bouncing, it's not flickering, it's just one solid band or cone of plasma. All right? If you look at the nebulizer or the spray chamber, you can see there's a cloud of sample going around inside of it. As soon as the argon hits the cloud, it's formed, and then it just draws it right up into the torch. All right? Over here on the sampler, I have standards that I made. I made from the plasma cal bottle here. It has 14 different metals on it. They're all at 50 ppm, and I dilute them down to make a 0.5, a 1 ppm, and also a 2 ppm. That 2 ppm volumetric flask might have had a little bit of an accident, and it's no longer with us. We should have a moment. That's good. So,
should we write that in our procedure?
yes, I would. Yeah, we had a moment for the volumetric flask. All right. So we have 0.5, 1, and 2 ppm. Okay. Going in, we have a 0 as well, which is that ultra pure water. I make the water over there in that little unit. It's called a millipore filtration apparatus. And what it does is it takes, okay, so we make distilled deionized water, right, which is a 3-stage process. Basically, it's double distilled, and then it's double deionized, and then finally we take it over there. As I said, the water that comes out of there is about 14 mega ohms. Actually, it's 18 mega ohms, but it only stays that way for about a half an hour. It starts absorbing things from the atmosphere. So that's our 0, and we acidified all of them the same way that we acidified all of your water samples. Okay? So now the very coolest part of this instrument is the sampler. And I had to teach it. When it comes in, you have to show it that, you know, I have 60 tubes over here and 60 tubes over there. I have to tell them what size they are. Basically, it has to learn itself. You have to teach it where things are. Okay? Make sure it's lined up properly, and then you just check. You let it go through a routine, and basically it goes to all the extremes and makes sure it's swinging the tube properly. All right? This runs a little faster at the beginning of the sample, just to flush everything that's in there out. Right? So there's just your sample going to go into the cone, and then it starts taking the readings. So just to show you up here, multiple wavelengths for each one. There's 4 for arsenic. There's 2 or 3 actually for each metal all the way across down to zinc. All right? And the hopes are that at least one of them is going to give us a good calibration. That's the hit and miss method. When you fine-tune a method. If you know your samples, roughly where they're coming from, what kind of chemical background they have, you can make it a lot shorter, a lot smaller, and roll up. Okay? These samples take roughly, each sample takes 4 to 5 minutes, say 4 minutes to run. So 60 samples later, that's quite a long time from now, it'll shut itself down in the middle of the night. And we'll have the analysis in the morning. What I'll give you is one column with each sample that we ran for each different metal. I won't give you all the different wavelengths I used. I'll just use one for the best. All right? If we were going to run a matrix modifier, we'd have to run another line here. That's what this extra setup is on the peristaltic pump. And I would be mixing that in with the sample before it hit the nebula. Okay, so it's, but I don't have to do that in this case. There's our zero done. My favorite part, watch. Yeah, it just cleans itself off. This is always getting water pumped into it from the diluter, and it just kind of rinses itself off and makes sure there's no cross-contamination from one sample to the next. It does a very thorough job. And that's about it. It will start running each of the